Welcome to our next video, which is about the normal distribution, given that we've finished vectors now. I've got a graphics tablet. I just need to see if I've got the hang of this. Yeah, kind of. Well, the normal distribution is a classic bell-shaped probability density function, which fits many types of data from the real world. You can see an example here, which is weights of 7,500 people. The basic idea of the normal distribution is many of us lie in a kind of an average zone here in the middle, and very few of us are at the extremities of a very large value of weight or a very small value of weight. And many things in nature and science follow that pattern. The notation is that the random variable is distributed normally with parameters the mean and the variance sigma squared. So here are 4 examples of normal distribution probability density functions which have this equation. You shouldn't be scared of that. We usually just use our calculator to do calculations with this. Pause the video and see if you can match up the distributions with their graphs. Pause the video. Well, we can see 2 distributions that have mean 20 and different variances. And remember, the variance, the bigger the variance, the more spread out the data. So it shouldn't come as any surprise that these are as follows, because the red graph, the data is more widely spread out than the blue. And these have means 30 and 40 respectively. So the axis of symmetry is x equals mu. And what about the maximum value? Well, there's a quick and easy way to deal with that. If we imagine the probability density function here when x is mu, then of course this simplifies to 0. So e to the power 0 is 1. You're left with this. And then the square root of 2 pi is approximately 2.5. So we can approximate the maximum value as 2 divided by 5 sigma. And we can see that in action here. So given this distribution, what is this probability? You can see straight away, since the mean is 3, and this is to the left of the mean, but not the entire domain, which goes down to negative infinity, this has to be less than 0.5. And notice, if the sigma is 2, then this little formula we discovered would be 2 divided by 5 times 2, which is 0.2 on the y-axis. Now, the graph is it's symmetrical, so like the unit circle in trigonometry, we can use that symmetry to help us solve problems, as we'll see. Here's another way to work it out using the calculator. Normal CDF. Remember, the CDF is the cumulative distribution function accumulating area underneath the probability density function. And here's the order: lower, upper, mean, standard deviation, LUMS. Now, in the first part of the video, we are looking at, given the event, what is the probability? Okay, I've been disturbed by the postman and then the cat wanting to come in. Let's see if I can continue now. Um, so these two events, what do you notice? They're equal. Well, um, as we're doing calculations with normal distribution, one thing you have to be aware of is always bear in mind a sketch of the situation. So if I sketch this normal distribution curve, even a really bad sketch where I put the mean in the middle, which is 3, and then the event here is 4, and think about this probability, and then the other event here with 2, and think of this probability, you can clearly see by symmetry those are going to be the same. So like the unit circle in trigonometry, a simple sketch can bring home to you a simple fact that is important. And there's a more accurate sketch done with the TI Inspire. Beautiful. Okay. With your calculator, you could work out these events right now. I think there's a misprint round about here. That should be X. Otherwise, it doesn't really make sense. Okay, that'll do for now.